Imagine the universe as a giant echo chamber. This is the legacy of the Big Bang, the event that brought our universe into existence. The echo? It's called the Cosmic Microwave Background Radiation, or CMBR. CMBR is a faint afterglow of the Big Bang, a whisper of energy that permeates all of space. We can't see it with our eyes, but special telescopes can detect it. By studying CMBR, we can learn about the early universe. It's like finding a baby picture of the cosmos, a snapshot of a time when stars and galaxies had not yet formed. The universe is vast, but it's not empty. It's filled with light, energy, and matter, some of which we can see, and some of which remains hidden. CMBR falls into the latter category. It's a faint signal, a whisper of energy that pervades all of space. But don't let its faintness fool you. CMBR is one of the most important discoveries in astronomy. Imagine a firecracker going off. The initial explosion is bright and intense, but it quickly fades, leaving behind a wisp of smoke. CMBR is like the smoke, the remnants of a much larger event. To detect this faint signal, scientists use specialized telescopes cooled to extremely low temperatures. These telescopes filter out other sources of radiation, allowing them to focus on the faint whisper of CMBR coming from the depths of space. Sometimes the greatest discoveries are made not by design, but by accident. In 1965, physicists Arno Penzias and Robert Wilson were working at Bell Telephone Laboratories. They encountered a strange interference, a persistent hiss that seemed to be coming from every direction. After checking their equipment and cleaning pigeon droppings out of the antenna, the hiss persisted. They had stumbled upon one of the most important discoveries in astronomy. The mysterious hiss was actually the afterglow of the Big Bang. Penzias and Wilson were awarded the Nobel Prize in Physics in 1978 for their accidental discovery. CMBR is more than just a faint afterglow. It's a snapshot of the universe as it existed just 380,000 years after the Big Bang. Before this time, the universe was so hot and dense that atoms couldn't form. As the universe expanded and cooled, electrons and protons combined to form neutral hydrogen atoms, and the universe became transparent. The light that was once trapped within the plasma was suddenly free to travel through space. This light, stretched and cooled over billions of years, is what we now observe as CMBR. By studying the subtle variations in the temperature and polarization of CMBR, scientists can learn about the conditions present in the early universe. These variations provide clues about the distribution of matter and energy in the infant universe. Imagine looking up at the night sky and seeing not stars, but a faint mottled glow coming from every direction. That's what CMBR looks like, though our eyes can't see it. To map this faint glow, scientists have launched space telescopes like COBE, WMAP, and Planck. These telescopes have created detailed maps of CMBR, revealing the subtle temperature variations that hold clues to the universe's early history. The maps show a universe that was remarkably uniform in temperature, with tiny fluctuations that represent the seeds of future structure. By analyzing these maps, scientists have determined the age, composition, and geometry of the universe with remarkable precision. They have also confirmed that the universe is expanding and that its expansion is accelerating. When we look at distant objects in space, we're seeing them as they were in the past. This is because light takes time to travel. The farther away an object is, the longer it takes for its light to reach us. This means that when we look at the most distant objects in the universe, we're seeing them as they were billions of years ago. CMBR represents the ultimate limit of our cosmic vision. It's the oldest light in the universe, emitted just 380,000 years after the Big Bang. When we study CMBR, we're peering back to the very edge of the observable universe. The discovery of CMBR was a watershed moment in astronomy. It provided compelling evidence for the Big Bang theory and gave us a glimpse of the universe as it existed in its infancy. But perhaps more importantly, it reminds us of the vastness and mystery of the cosmos. As we continue to explore the universe, we are sure to make even more astonishing discoveries. So the next time you look up at the night sky, take a moment to contemplate the cosmic echo that surrounds us. It's a faint whisper from the dawn of time, a reminder of the incredible journey that our universe has taken, and the countless wonders that still await our discovery.